Good morning, everyone. It's really inspiring to hear two talks earlier, and if I get it right, this WashU Engineering Center is the first one in the state of Missouri, right? Yeah, this wonderful, yeah. The first talks really have set a wonderful stage for me to talk my project here. My project is much narrow scoped. It's just pretty straightforward. We had a project kickoff meeting last week in San Diego, organized by the Department of Energy, and several of us, Dr. Pani and Joshua, we went there for the exhibit, the Energy Summit at the Department of Energy to talk about this one. I just used the same slides, so you can see that sort of a logo from ARPA-E program is still there. The project is on rare earth element extraction there. The concept, the steps involved is pretty simple. Okay, we start with this mining waste. There are a lot of acid mine drainage, acid rock drainage there. And then we develop this material that is selective for specific rare earth element. And we build this, build this column there to extract those individual rare earth element. And then we have this stripping column to take it out. And then, of course, that could be end up with the product there. Of course, the real process could be much more complex. If the water sources have many other components, we need to do a lot of purifications there, pre-treatment, so we could apply our material. And also, if the product coming out does not meet the standard for sale, for market there, we need to do some additional purifications there. Okay. Our project really is try to address a challenge with rare earth elements in the United States. And as we mentioned that this rare earth element is really essential for the nation here. If you look at all the products that could use this rare earth element, about 70% or over 70% of these high-tech products have to use this rare earth elements there. But then look at these sources of rare earth element. Most of them are coming from China. US have some, but this US one is mostly on this sort of, not on the heavy rare earth element side, but on this sort of lighter rare earth element side. That they're still important, but this heavy rare earth element is really a challenge there. So among many types of critical materials, rare earth element shortage or supply chain sort of disruption could be very important, is the highest. Okay. I think we have these opportunities here to look at this waste mine system there. Some of you may, some of you may not. Missouri actually is one of the major mining states. Started with this lead mine, used to be the #1 in the world. There are a lot of mining activities, those old lead belt, new lead belt there, Joplin, those area, tri-state. There are also this iron mining activities there. So here is an area with this iron mine that has kind of practiced, was in operation for decades. Here is the maintaining. There's way over 20 acres there. We went there to take some sample there, and you have this acid mine pond. Okay. It turns out that in those waste materials, you have high concentration of rare earth element. For example, here, the neodymium could be over 400 ppb, and terbium is way over 100 ppb. Okay. If we could extract that, we did have some preliminary experiments to show that we can selectively extract those materials. I think that is a good approach for us to address this challenge. And also, I'm in the Department of Civil and Environmental Engineering. I have been working on this hazardous waste management, and this waste site remediation is important. If we could couple this waste site remediation with rare earth element extraction, I think by this push and pull effort there, we should make this viable economically. What we want to do is first in this project identify a number of waste sites we could work on. We'll try to characterize the strengths there and evaluate whether large-scale operation could be feasible. And then to the end, we need to develop this pilot continuous operation system that will be able to field test it in the field. Of course, still at a very small scale. And the purpose for this project is to lay the ground. Eventually, we could commercialize this technology. So if we look at this commercialization there, we need to look at the market. It's still significant. And we need to look at what kind of stakeholders, market we could address. And that will include government and private industries there. And we need to look at many competitors there. And some of those are domestic, some of those are international. And then we need to look at what kind of resources we need to help gap this knowledge there. And that is a team with 3 organizations, University of Missouri and Quasar Energy Group, and as well as this University of Colorado there. And those are sort of assigned tasks for each of the team there. Okay. So to conclude, we are very excited with this project, and I want to thank the support by the college, grant office, like IP office, to lay the kind of ground to this proposal there. And also, here is the team with the 3 organizations. I'm very excited to be able to work with the team to see we'll be able to address some of these issues. With that, I will end. I see the timer here. Okay.